Steam sterilization utilizes moist heat in the form of saturated steam under pressure within an enclosed environment. It is the most dependable method for sterilizing items that are not heat, moisture, or temperature sensitive. Steam sterilization, heat alone can destroy microbes, but the process is accelerated with the addition of moisture and pressure. Steam sterilization will destruct all microorganisms, including spores, on inanimate surfaces. Important factors for steam sterilization is time, contact, temperature, pressure, and moisture. As you see in Table 716 and Table 717 on page 158, minimum time required for sterilization will depend on the temperature and the type of cycle that's going to be used. For contact, just with any liquid disinfectant or sterilant solution, the steam must come into contact with all surfaces. For temperature, pressure, moisture, and air. Steam is a water vapor. When the water is heated, the steam bubbles rise to the surface, burst, and release a vapor. The steam is a saturated steam and contains the maximum amount of water vapor, which is 97 to 100% relative humidity. Moisture plays such an important part of the steam sterilization. The thermal destruction of microbes is the result of the denaturation and coagulation of proteins within the cells. This moisture does act as a catalyst, so coagulation can occur at lower temperatures as compared to the higher temperatures when there isn't moisture. Moisture allows the use of lower temperatures than normal to denaturate the proteins and the microbes. Direct steam contact of all surfaces must occur for an item to be rendered sterile. The quality of the steam should be at 97%, with the remaining 3% being liquid water that's present in the autoclave. All air must be completely removed from the chamber if efficient sterilization of materials is going to occur. I will speak to you in the next components about the two different air removal options. There are three major types of steam sterilizers. You have your gravity displacement sterilizer, your dynamic air removal, which is also known as a pre-vacuum, and you have your immediate use sterilizer, which is also known as flash sterilization. Gravity displacement sterilizers rely on gravity to remove the air from the sterilization chamber. This is very important, and a general cycle includes the conditioning phase, exposure phase, exhaust phase, and drying phase. Your pre-vacuum steam sterilizers, also known as your dynamic air removal autoclaves, are similar to construction except for they have a vacuum pump in the system that removes the air. Before the steam is injected into the sterilizer, the air is removed from the chamber, so its cycle time differs. A typical cycle would be seen as air removal, conditioning, a second air removal, exposure, exhaust, and drying. There are several advantages to your dynamic air removal steam sterilizer. One, it increases the speed of operation and it lowers the total cycle time. It's more efficient in removing air than gravity. It's not as dependent on the positioning of the load contents, and condensation is produced during the preconditioning phases, which also reduces the actual cycle time. There is a test that's very unique for this particular sterilizer, and it's called the Bowie-Dick test. This test is a pack that's placed horizontally on a sterilizing cart on the front bottom shelf of the chamber. The front bottom shelf of the chamber is actually the area that is hardest for the sterilizer to reach. That's why that's the chosen area. There must be a test ran on the sterilization pack in order to render the cycle complete. There must be an intensity of color change to the heat-sensitive ink, and there must be a uniformity to the color change. Everything must be documented professionally. For flash sterilization, that is referred to as the immediate use steam sterilizer. Normally, immediate use steam sterilizers are located in the substerile rooms in the OR suites. A lot of times it's a necessity for an item to be sterilized immediately. In situations such as this, it would be that an important instrument was dropped on the floor, an important instrument needed to be turned over for a certain surgeon. At no point in time should implants be flash sterilized for immediate use. This sterilization is accomplished with items that are unwrapped and placed in perforated instrument trays. These containers are available from most commercially manufacturers. They can be performed in a gravity or a pre-vacuum sterilizer, and you would use the same times noted for both. I would like to bring your attention again to page 158 for minimum cycle times in the gravity displacement steam sterilizer and the dynamic air removal system. I also would like to take this opportunity to bring about the advantages and disadvantages of steam sterilization. Human error is the biggest factor in the disadvantage of steam sterilization. It is the most dependable and it is relatively quick. It is non-toxic and leaves a non-toxic residue on the items. It is readily available as well. So in speaking about the minimum exposure, your most common temperatures are 250 to 275 degrees Fahrenheit at 15 to 17 psi, which is your pressure readings. Dynamic air removal, you'll see somewhere around 270 degrees to 275 degrees at 27 to 30 psi. We must monitor the sterilization process. There are 4 major areas that can be in ways that can be monitored: mechanical, chemical, biological, and the 4th being administrative. Administrative is primarily the professional documentation that must take place at all times. There must be a permanent record of each of these. When looking at administrative documentation, please know that temperature, pressure, and time must be monitored for all parameters to exist. Newer autoclaves mostly have digital recorders and will also produce a printout, which is extremely helpful. For chemical methods of monitoring, there are chemical indicators that are used externally and internally to verify that an item has been exposed to all conditions related to sterilization. The chemical indicators validate that those contents were exposed to the temperature, the humidity, the sterilant, and all other avenues. The chemical indicators are assigned a class. You have class 1, which is a process indicator, a class 2, which is used in very specific tests such as the Bowie-Dick, a class 3, which is single variable indicators, class 4, a multivariable indicator, and a class 5, integrating indicators. These are the most accurate of all the internal indicators, and they're used as pack control monitoring. Class 6 is emulating indicators. These chemical indicators consist of paper that's been impregnated with a dye that changes color in the presence of temperature and sterilant. The most popular type is autoclave tape. This tape is used for packaging. It is made with diagonal lines. Once these diagonal lines are exposed to the process, they are changed to a black coloring. There's also internal steam chemical indicators. They're placed inside the packages, the pill packs, and instrument trays. These indicators should be placed in the area of the package where the greatest challenge exists for penetration. The internal indicator is red when the package or tray is opened at time of use. The indicator tape, if it has not uniformly changed to black, then the package could possibly be contaminated and not exposed to correct sterilization procedures. Locking devices and filters on rigid instrument containers also contain this chemical indicator. It is a dot that changes to black during the steam sterilization process. Paper load cards on the outside of the containers also contain a strip of chemical indicator ink that turns black once exposed. Your biological indicator is a device that contains a specific microorganism, and it's killed when it's exposed to sterilization conditions. The microbe chosen is normally in its spore stage and very difficult to kill. The biological indicator test only guarantees that the items are sterile and the conditions are necessary for sterilization have been met. Very importantly, the BI for steam sterilization contains the bacterial spore Geobacillus. This microbe has been determined the most resistant to be killed by steam sterilization, but yet it's harmless to humans. Most institutions have this BI indicator in a commercial test pack that is a vial of this microorganism. These test packs offer many advantages and are placed in the area of the sterilizer most difficult, or considered the coldest area, which we discussed earlier. The BI vial goes through the sterilization cycle. It's removed. It's taken out to be incubated. The growth medium is released to cover the spore-impregnated disc once it's crushed. The nutrient broth is red in color. After incubation, if the liquid remains red, the results are considered negative, meaning the spores have been killed. If the broth turns yellow, the results are positive, meaning the conditions for sterilization was not met, the spores were not killed, and the items that are in the load are considered non-sterile. Steam biological indicators are normally incubated for 24 hours before the reading has occurred. Ethylene oxide gas sterilization is also referred to as ETO gas sterilizing. Gas sterilization is used mostly on plastics and rubbers or any other material that high steam temperatures cannot penetrate. Ethylene oxide gas is a chemical gas sterilization that is very toxic and has effects that range from skin irritation to respiratory difficulties, headaches, and nausea. The CDC has also stated it's been linked to cancer, reproductive difficulties, and chromosomal alterations. Therefore, ETO gas sterilization must be in a closed room that's specifically designed for this particular sterilization type. It must have the ability to vent the extra gas at the end of the process without releasing it into the atmosphere. Several factors are required for ETO gas sterilization. One is the gas concentration, which comes in cylinders and are attached to the sterilization machine. The other is the temperature. Most operate somewhere between 85 degrees Fahrenheit to 145 degrees Fahrenheit. Humidity. Humidity is kept between 30 and 80% in these processes. Time. Sterilization for ETO gas is a very lengthy process. Instruments must be clean, dry, and free of lubricants. The gas cannot penetrate oils. If water is present in the tubing or the lumens of the instruments, then it's considered invalid. Aeration time is the most time-consuming part of the ETO gas process. All items must be aerated for 8 to 12 hours, depending on temperature. The EPA has a concern over the effects of ETO gas on personnel and the environment. The only ETO gas sterilization chamber for Atrium Health is located downtown in Charlotte. You will find very big discoloration differences with ETO gas as far as the chemical indicators. For the mechanical indicator, you will still have the digital printout. For chemical, you will have a tape that's green in color with diagonal lines with the ink. Once the ink is exposed to the gas, it changes to a brown color versus the black that you're normally used to seeing. The BI monitoring for ETO gas is Bacillus atrophius. This microbe is the most resistant for ETO. The same process is followed for the ETO gas sterilization as followed for steam biological indicators. ETO gas sterilization is monitored more frequently and is normally monitored with each load. Lastly, you have other sterilization errors. Hydrogen peroxide gas plasma, or otherwise known as your STERAD, uses a gas at low temperature to sterilize heat or moisture sensitive items. This is your most common that you'll find, but due to it's much safer than the ETO gases. Hydrogen peroxide is a highly reactive molecule that penetrates the packaging materials and reaches all surfaces. This plasma creates the free radicals. The biological indicator for HPGP is Bacillus atrophius. The other options of liquid chemical sterilization is the Stera system, which is also known as peracetic acid, and you also have the glutaraldehyde, which is also known as Sidex. The Stera system is very popular with endoscopic instruments. Those are sometimes located in the substerile room as well. Ionizing gamma radiation is used in industrial manufacturing for the pre-packaged products that we use in the OR. It has irradiation that produces a thermal and chemical energy. This sterilization method is primarily used radioactive gamma rays or beta particles that sterilize our products. Ozone gas sterilization oxidizes bacteria and destroys them that way. Much like plasma sterilization, it's used limited by the products suitable for sterilization. Ozone is destructive to rubber and plastics and corrodes some metals. This method cannot be used for long cannulated instruments. A generator converts oxygen into ozone. Ozone has the ability to penetrate cell membranes and cause them to explode. At the end of the sterilization cycle, the chamber is purged of ozone, which is replaced with oxygen. These machines have a cycle time of up to 60 minutes and can be used with some metals. Vaporized hydrogen peroxide, or VHP, uses hydrogen peroxide in its gas form. Concentrations of 30% in vapor phase, hydrogen peroxide sterilizes in less than 30 minutes and requires no aeration time. VHP cannot be used with paper wrappers. Nylon and rubber products become brittle, and it can also be corrosive to some metals. Event-related sterility refers to the concept that when an item is used is when it becomes unsterile. There's no longer time-related sterilization. It is the event that causes the item to be rendered unsterile once the seal is torn or broken.